Hello everyone. Welcome to my presentation on InfoSync, information synchronization across multilingual semi-structured tables. What is the problem of information mismatch? Let me illustrate it with an example. These are two tables of the same entity in different languages as found on Wikipedia. If you look closely, you'll see that there are several inconsistencies between the two tables, such as a value mismatch, rows present in one table that are not present in the other table and vice versa, and also different cultural contexts across the two languages. Since Wikipedia is completely humanly edited, there is a lot of scope for different information, probably even contrasting across multiple languages. If we look at the magnitude of the problem, we see that Wikipedia has articles in more than 300 languages, and English is the most commonly used one with about 23% of all pages. However, it has disproportionately more editors with 76% of the total editors. This shows that most of the other languages may not even be up to date and contain wrong information. And to solve this problem, we have contributed a dataset of 100,000 Wikipedia Infoboxes across 14 languages in 21 diverse categories, as well as a set of 3,500 manually annotated alignment table pairs, including a metadata analysis of the alignment pairs. We propose a two-step solution to information synchronization. The first step is information alignment, where we find rows with similar information across the two tables. This is then used in the next step, which is information update, where we use the previous results to update the missing or outdated information. Now let's look at the dataset details of the dataset that we have prepared. We have the dataset of tables in 14 languages. The languages were chosen such that we covered all continents and all the different resource levels. We also ensure that the languages are better represented by choosing the entities which have info boxes in at least 5 different languages to ensure that no language dominates over the others. We selected 21 diverse categories from airport to food that can be seen here. Now let's move on to the method that we propose. The first step is information alignment. We propose a 5-step incremental method where we relax the rules sequentially. The first step is the corpus-based method, where we align rows based on the cosine similarity of their keys with a certain threshold. These alignments are then cross-checked across tables in the same category, and we choose the alignments using a majority vote. If we take a look at the example, the keys of nationality and sport are directly aligned using the corpus-based method. Now, we move on to the next step, which is the key-based alignment, where we relax the rule of looking across all tables in a category and only look at the two tables we are aligning right now. We align the keys with key similarity score greater than a threshold, given that they are mutually most similar across the two tables. And in this case, the Born and the weight keys get directly aligned. Then we move on to value-based alignments as well. Now we look at both the key and values, and such that if the similarity is above a threshold, the rows are aligned given that they are mutually most similar as previously already discussed. So the country and the retired age is now aligned as well. Now, if we move on, we can now further relax the rule of having the keys to be mutually most similar across the two tables, and that is what leads to key value unidirectional alignments, which is very similar to the bidirectional except with the relaxation of that rule. And in this case, the born key is now also aligned with birthplace. Now we move on to the last step, which is the multi-key step. And in this step, we aim to align rows where a row in one table may be aligned to more than one row in another table. We do this by saying that if we merge the values and the similarity score of the merged value goes higher than the most similar key, then the rows are aligned. Right? In this case, the born is multiple aligned to birth and birthplace. Right? Now, if we look at the results of our alignment statistics, we see that we beat most state-of-the-art multilingual models comfortably. If you look at the F scores of the English to X alignments and X to Y alignments, where X and Y are different languages, we see that in almost every single metric, our method clearly outperforms all the other multilingual models. Now, let's move on to our next stage, which is the information updation. We propose a rule-based methods that uses alignments from the previous step to update the tables. We propose 9 major rules to dictate our updates, such as row transfer, time-based rules, etc. etc. Now, let's look at an example update. In this case, the full name key is absent in the Spanish table and that is directly transferred. If we look at the died key, we see that in the Spanish table, the age is not mentioned and this is directly substituted. Australia is also replaced by Western Australia. Similarly, there are other missing rows that are transferred or either appended to the Spanish table, clearly showing a case for updation here. Now, let's take a look at our updation results. We see that the row transfer is the most common update, showing that a lot of tables actually often contain missing information. With just the rule-based method, we are actually able to update a high number of rows. We took this a step ahead and went ahead and tested our method on Wikipedia Live using the human in the loop updates, where a human evaluator would update Wikipedia Infoboxes using the results of our method. We are able to achieve a high acceptance rate even after several months of the edits, further showcasing our method's effectiveness. Now, let's take a look at an example live update that is actually present live right now on Wikipedia. The column 3 shows the updated Korean info box, and column 1 and 2 show the original boxes. Right. In conclusion, I hope I have convinced you that information synchronization is a common and rampant issue for semi-structured tables, especially in our case study Wikipedia. Our method has two major steps: information alignment, where we outperform the other approaches with an F score of greater than 0.85, and the rule-based updation method that receives 77.28% approval on Wikipedia using the human in the loop testing. Thank you.